Hello guys, welcome back. In this video, I'll be discussing how to find kth smallest element in an array. If you observe the given input, we're having a size as 5 and the elements in the array are 1, 2, 3, 4, 5 and the k value is 2. Now for this particular image, if you want to find the second smallest element, the output would be the value 2. Similarly, let us try to look at some other input. Here my input is the same value size 5 and the elements are 5, 3, 8, 2 and 6. Here my k value would be the value 3. Now from these given elements, if you want to find the third smallest element, the output would be the value 5. For this particular input and the particular output, there are a lot many ways to solve a problem. I'll be covering the most important two methods to solve the problem. Let's quickly get into the method 1 logic. The method 1 logic would be very simple and the easiest approach. The first thing what comes to in our mind is we need to just simply sort the array. So if you observe in the second input, we're having the elements as 5, 3, 8, 2 and 6. If you want to sort this particular array, the elements would be the value 2, 3, 5, 6 and 8 would be your array. If you want to give the indexing for this particular array, the indexing would be the values from 0 to 4. Now, if you observe, at last we need to return or simply print the value which is present at the k minus 1 index. Here our k value is the value 3. Now, if you just take the value k minus 1, the value would be 2. The element which is present in the k minus 1 index would be the value 5. That would be our output. Now, for this thing, we need to sort the logic. So how do we sort? There are a lot many sorting techniques to sort like bubble, selection, insertion, quick as well as merge sort. Out of all these sorting techniques, how to find the best optimized sorting technique? How do you find the best optimized sorting technique? We do that by using time complexities. For bubble, insertion and selection, the time complexity would be order of n square. So just we can ignore the three sorting techniques and among the other two sorting techniques like quick and merge, the sorting techniques are very optimized. The time complexity for these two would be order of n log n. So among these two sorting techniques, the best sorting technique would be quick sort. Why quick sort in the sense? Merge sort takes an extra array or an extra space for sorting the array. So among these two sorting techniques, quick sort would be the best optimized sorting technique. Now let's quickly dive into our code. In the C programming language, first we include our standard input output library header file. After this, we simply write our main function. Here, first thing to be noted, we need to scan the value size. For just scanning the size value, it will take a variable name size and scan the value of this particular size by using address of size. After that, I need to declare an array of size, the value size. So let me declare an array of size. Done. So for iterating the array, I need to have a variable called I. Let me also declare that as well. Now just try to scan the elements by using a for loop and just scan the values to ARR of I. So this could be the scanning the values into an array. After this, we need to scan the value of the value k. Here k value would be some value what will be given by the user. So done scanning the value of k as well. After this thing, we need to write the main logic. So here comes the thing. So here in our main logic, we discuss something about called qsort. Qsort would be of quick sort algorithm. So for writing this qsort function, basically qsort takes four parameters. The first parameter would be the name of the array. Here our array name is ARR. So you pass the first parameter as ARR. The next one would be the size of the array. So here the size is a variable which defines the size of the current array. And next parameter would be size of each element of the array in bytes. So the array elements are of type integer. So next would be and size of integer. The next one should be the comparator logic. So this logic would be some comparator logic. Before getting into that, in order to use quizsort, we require something called stdlib.h. So that you need to include that as well. So for writing comparator logic, comparator returns some integer value and it accepts two pointers. So ptr1 is one pointer and ptr2 is the other pointer. So here we want to access the value which is present at ptr1. So how do we access that? simply star ptr1. Star is nothing but evaluate operator. So here ptr1 is of void. So if you want to convert the particular value to an integer, first we need to dereference that pointer to an integer pointer. So ptr1 would be typecasted to an integer pointer. Similarly, if you want to access value 2 of the pointer 2 which is present, so value 2 would be the value presented pointer 2. So now we return something called value 1 minus value 2. Let us assume there are two values called 5 and 8. So 5 would be value 1 and 8 would be value 2. So when you return the value 1 minus value 2, 5 minus 8, the value would be minus 3, which is less than 0. So you're returning the value which is less than 0. So based on this integer value which is being returned, the logic either it might be ascending, descending, or any other logic would be decided. If the value is negative, the logic would be ascending. If the value is positive, logic would be descending order. So this is a value which is being returned by the comparator function. So after this thing, the last thing what you need to do, you need to simply print the value which is present at the index k minus 1. This is the final step. So this q sort as well as this printf should be written the same code in the main logic in the main function, and this comparator function should be written before the main function. This could be the method 1 logic. See you guys in the next method. Thank you.